up, ladies and gentlemen? Here we go. First video for section 2 of chapter 6 is, here's the essential question. How do you evaluate and graph polynomial functions is the idea in section 2 of chapter 6. Now in this video, it is going to be the basics. I gave you a graphic organizer. It's actually the links right there. You can download it and print it if you don't if you didn't get it in class. But I'm going to give you the basic knowledge, vocab, verbage that you're going to hear throughout this section and beyond. So we're very, very good when we get to this evaluating piece and then even the graphing piece, okay? So on your graphic organizer, here's your definition of what a polynomial function is. And of course, the first three letters, F-U-N, are the most important function. It is, a polynomial function is a function where the exponents are all whole numbers. And the second thing is, this is an or, it's and. Both of these must be true in order for these things to be polynomial functions. The other thing is the coefficients are all real numbers. So, for example, here's question, or not, example number 1, 2, and 3. It's going to pop up here. You can throw them on your graphic organizer. Example number 1, if you look at the exponents, they're all whole numbers. That's a 2, that's a 1. There's no exponent here, so that's good. Well, there is on top of the 3, but whatever. So check on that one. So then, let me pull this up here so I can write this. So that's good. At least, first thing is checked. All those exponents are good. Then it says the coefficients are all real numbers. Well, that's a real number, that's a real number, and that's a real number. So beautiful. So the first one is, yay, it is absolutely a polynomial function. Example 2. Well, let's look at the exponents. That's a whole number, and there's a whole number. Great. So they're all good. The coefficients are all real numbers. Check. That is also a polynomial function. Example 3. Look here. That exponent right there is not a whole number. That's a variable. Now, could it be a whole number? Sure. But man, you could put pi in there. You could put 2 raised to the pi power. Why would you? I don't know. But x is anything. It could be a variable. It could be a letter. It could be anything. It certainly doesn't have to be a whole number. I mean, it could be an irrational number, like I said, pi, or anything that is an irrational number, or an imaginary number. I mean, you can raise. It could be like 2 to the 2i power. Well, that's an imaginary number, so therefore that wouldn't hold a polynomial function. So this one, oh no, so sad. It is not a polynomial function. Hey, but I can tell you this: the coefficients at least are real. Great. Means nothing though, because both of these must be true to be a polynomial function. So there's your first thing. Okay, on to this. Onto your folder, well, you see this thing right here, this little blast out thing. Well, in this is going to be an example, and from this example that I'm going to have you put on the screen, or on your foldable, on your, what am I saying, talk Motter, onto your graphic organizer, we're going to use this to get a couple more definitions. So you see, it's a function f of x, great. It equals 2x to the 4th, equals 3x to the 3rd, equals, stop, minus 3x to the 3rd plus x minus 12, whatever. Okay, the first thing, and I'd recommend if you have a highlighter or different color pens or pencils, get them now, pause the video, and get them now, because there's going to be 3 different colors that I'd recommend you using, and here's the first one. That 2 right there, that is in front of this x to the 4th power thing, that coefficient, it is by definition called this. It's called the leading coefficient, and by definition, it is the coefficient of the biggest powered term. And you can see 4 is the biggest power of all the ones that's here. So it's the coefficient that goes along with the biggest powered term. That is what we call the leading coefficient. I hope you hear me and you hear me good on this, or you hear me well. I guess it would be for you English people. It doesn't always have to be the first number. Just because it says leading coefficient doesn't mean it's the first coefficient. It's always the coefficient that goes with the biggest power term. That's the first thing. Second thing, that little number way out there that has no variable to it, that thing right there is called the constant term. Has no variable. Is it always on a function? No way. Doesn't have to be. But many times in polynomial functions there is a constant term. So, last thing, that little 4 that's right there that I talked about before, it is the biggest, highest exponent power, whatever you want to call it. That right there is a very important thing called the degree of the polynomial. So the degree of the polynomial is the biggest, highest powered exponent, whatever. It isn't always the first one, but it is the biggest one. So that's the degree, and that's mostly important when you get to the next thing. So there's your summary. You got leading coefficient, you got constant term, and you got degree. Now, flip your, actually let's not do that. Let's do an example. So when you look at these examples here, it says state the degree, the leading coefficient. I even could ask the constant term too. So in this first one right here, the leading coefficient happens to be -2 because it's with the biggest power term. In fact, 7 is the degree. What's the constant term? Oh, there isn't any. That's okay. It happens sometimes. Technically, actually, the constant term would be 0, truthfully, because even though it isn't there, you'd still put like plus a 0 in your mind. So the constant term is 0. Okay, there's the first one. Second example. Oh, look, it's not really in the same exact order, if you will, as this one is. Over here, I had to look the whole way over to the end, to find the biggest power term. So 2 would be my degree. 1/3 is my leading coefficient, positive 1/3, because positive goes with it. And then my constant term is right here. It's positive 24. Cool. Let's go to the next one. Well, when I look at this, I need to look for the highest power term. Bingo. Wow, I have to go the whole way to the end again. So 9's my degree. Positive 3 is my leading coefficient. And I got to find one that doesn't have an, oh, look, there's no constant term. Again, it would be just like this one up here. It would be plus 0. But that's a scoop. So you got degree, you got leading coefficient, and now you got constant terms. So let's now pull this together. Turn your paper over, and you're going to see this chart. And on this chart, we're going to focus more on just the degree of these polynomials, because the actual degree is what we use to name these polynomials. Okay? As you see popping up here on the screen. The degree is the thing that determines the actual name of it. And here's what I mean. On your little chart, if you have a degree of 0, for example, you have a function where there is actually no variable, that's a constant term. There's no variable in it, there's no squared thing, there's no cube thing, there's nothing. It's just a constant term. That has a special name. It's called a constant polynomial function. How about that? By the way, over here to the right, a quick sketch of this particular graph. What I'll do for you is this. Let me show you what it looks like, but I will tell you in this case, it looks exactly like a straight line. Looks exactly like that. Yep, you got it. You can write that. That's exactly what it looks like. On the coordinate plane, it's just a straight horizontal line. It goes across there. In fact, let me do this. Let me see if there's a way for me to think I can do this. Here we go. So I'll show you this example. So there it is. So f of x equals 4. It is just a straight line that goes right across, crossing the y-axis at 4. Beautiful. It's that simple. Okay, back to the PowerPoint. So let's say we have a constant, no, sorry, not a constant, a degree of 1, which would look like this. So you can see it's now 4x to the first power. So my highest power on a variable is a 1. That's the degree. That particular name is called a linear function, a linear polynomial function. Now, we've seen many of these. In fact, in Algebra 1, maybe even pre-algebra, you graph these things. We did it a lot in Algebra 2 here at the beginning of the year. But these guys, again, look like a straight line. Hence, it's called linear. Except, constants are always horizontal here when we're talking about functions. Oh, yeah. If it's vertical, it's not a function. It doesn't pass the vertical line test. That's why it's horizontal. When we're talking a linear function, remember, there's a slope to it. So it could go up to the right. It could be falling down to the left, a negative slope. This could be a positive slope line. That's a negative slope line. Specifically, if I graph this one for you, and I'll show you. Here, I'll take this one away. So 4x to the third, it looks like this. Oh, check it out. Makes sense. It goes through 3 on the y-axis. That's the y-intercept. And then the slope is up 4 over 1. Up 4 over 1. Up 4 over 1. So there you go. It's just a straight line. Okay? So you got that. You got linear. You got constant. What happens if we have a degree of 2? Ooh, if we have a degree of 2, then that function looks like that. And oh, we've just done a ton of these things. What is that bad boy right there called whenever you have the degree of 2? The highest power is a 2. Tell me. You got it. It is called a quadratic function. And oh yeah, these guys are parabolas. So they're U-shaped this way, remember? Or they're U-shaped this way. Oh yeah, they're parabolas. Now actually in this case you would know, since it's a negative leading coefficient. Oh, there's the word. A negative leading coefficient, you know it will be a frowny face. Specifically though, let me just show you so you got it. Here's your example. You take this away. So here you go. Boom. So there's your parabola. It's going down. The vertex is right here. We've talked about that before. Wonderful. So that is what a quadratic function looks like when you graph it. Let's move on to ones that you don't know. What happens if we have a degree of 3? Well, here's an example of one. You got negative 2x to the third power plus x to the first minus 5. Notice the highest power is 3. That guy right there, special name, is called a cubic function. What in the world does a cubic function look like? Actually, that would make sense because, listen, that's cubed. 3 to the 3 power to the third power is cubed. So cubic would make sense in the terms of the name. So a cubic function, what does it look like? Well, let me first show you before I draw a sketch. Here you go. So let me take this away and check this out. When I graph this one, degree of 3, it's a cubic. Oh, look at that guy. So it comes down here almost like a parabola, scoots back up, and then it bounces back down and goes that way. Oh yeah, all cubic functions look similar to that. They look kind of like an S shape. So what I would do over here is I would draw something like it goes like this, like that. This isn't quite right. It should be more down like this. There we go. Or it could actually start down here on the left, go up, bounce around a little bit, and then come up that way. Either way, a cubic function will look kind of like an S shape, kind of. Okay? So there's your third degree one. And the last one, a fourth degree polynomial. Whoa, these get funky, man. So you notice the highest degree over here in my example, which should be in your graphic organizer, is a 4. This guy right here, I know what you're thinking. Oh, 4 means quad, so quad. No, no, no. We've already used the word quad. So we got quadratic, which is 2. I know it's weird. You'd think it would be squadratic or something. Nope. Quadratic is this guy. Well, this thing right here has a special name. It is called a quartic. A quartic function. Yes, you'll have to memorize these different names and know them, what cubic and quartic and quadratic is. Now, what in the world does the shape of a quartic function look like when you graph it? Oh, fantastic question. I'm glad you asked. So let me take away this. Are you ready? This is going to look weird, but here you go. Bam! Let me back up so you can see it. Let me back up even more. There you go. So it actually looks like kind of a W. Yeah, it's kind of exactly what it looks like. Now, they always don't look quite like this, of course, but that's pretty much the general idea. They're either going to look like a W or they're going to look like an elongated U shape. Not quite a parabola because it's flatter at the bottom. But this is kind of what they look like. So what I do in your graphic organizer, I don't know, draw one that looks like a W, whatever, something like this. So they could be going up or they easily could be going down like an M. Well, that's a weird one, but whatever, you get the idea. So there you go. Constant, linear, quadratic, cubic, and quartic. And the last thing is this. What type, oh sorry, actually a couple examples. What type is this? Well, you have to look, no, it's not a quadratic. Nice try. You got to go over in here, find the highest degree. That's a third degree polynomial, which means that is a cubic. I shouldn't write this, it takes too long. That's a cubic function. This one right here, there's a first, there's a 2, there's a constant, oh, here we go. That's also a cubic function because it's the highest degree. So the degree of that polynomial is 3, it's a cubic. This one here, oh, look, highest degree is 4, so it's a quartic function. It's simple as that. And last thing, when you're asked to do this, which you're going to, when you're asked to write something in standard form of a polynomial function is this. It is when you actually take the polynomial and you write it, as you see, when the terms are in descending order of exponents from left to right. So that means when you write it in standard form, you need to look at the terms like this positive 2x to the third, this 3x squared, and this negative 5, and you need to rearrange them with the signs going with them, where the exponents go down in order. So you always start with the biggest one right there, that's the biggest power term. That would go first, and then this would go second, not because of the 2, it's just because it's the next highest power term, and then this would go last. So that's what standard form is when you're writing a polynomial function in standard form. So, like I just told you, this one right here, I would write 2x to the third plus 3x squared minus 5. That's it. This guy here, I take this and write it first, so 2x to the third, and the next one would be plus 5x squared, and the next one would be plus 3x, and then the last one would be minus 3. So it's in order. Notice it goes 3, 2, 1, constant term. This one right here, that's my highest term, so it's got to go first. Sign goes with it, so it's negative 5x to the fourth. Next one was positive 6x, and last one then is plus 2. So there you go. Congratulations. Phenomenal. You got it. End of show. There you have it. And ladies and gentlemen, welcome, welcome to section 2. We're going to use this knowledge and this verbiage to then again talk about evaluating these quartic functions and cubic functions and quadratics. And then we're going to talk about how we actually graph these things. Yes, you know what they kind of look like, but exactly when we graph them, it's going to be cool. So pumped up. We'll talk to you guys in class later.